Okay, Jenna, here we go. Problems 33 through 39. I got checking to make sure I got my calculator handy in case I need it. Yeah, we're solving logarithmic equations and exponential equations. There are a couple of tricks. Now, looking at this one, before I do anything, I can see the trick is going to be I have the log base 8 of an argument and the log base 8 of an argument. I'm going to end up just setting the arguments equal to each other. X plus 8 equals 9, and then that one's really easy. But here, unlike where I have a log on both sides, I just have logs on one side. So what I'm going to do is, like we did before, I'm going to put all of this together as one log statement, and then I'm going to rewrite it. Instead of the job being set things equal to each other, I'm actually going to rewrite this one. Okay, so let me show you what that looks like. Since I don't have a number out here that I have to put up as an exponent, and I don't have anything like that going on here, I just have the log of an argument equals the log of an argument. So I just get to say that x plus 8 equals 9, and then solve from there. Now, the one trick is, whatever answer I get better not make this parentheses section negative, because there's no such thing as the log of a negative number. If you don't trust me, look, log of -2, you get an error and the calculator blows up. Logarithms are graphed like this, and it's been a couple of weeks, so I'll just sketch that real quick. You don't need that for this problem, but you can't put a negative into a log function. So anyway, I subtract 8 and I get x equals 1. Now 1 is fine to put in there because 1 plus 8 is equal to 9, and so that's not negative. So there's number 33. Go to number 34 and watch how it's different. There's no log over here, so I'm not going to be able to just set the arguments equal to each other. What I'm going to do is write this as complicated thing as one log statement. So my first thing is I'm going to take the 2, I'm going to put it up here. The log base 12 of x minus 8 to the 2 plus the log base 12 of 4 is equal to 2. Now that I took that and wrote it up as an exponent, I can write this as one log statement. Because they're plus, it's going to be 1 log base 12, and these arguments times each other. So it'll be log base 12 of x minus 8 squared times 4, and that's all equal to 2. So now that I have it written as just one log statement, I can rewrite this. The base of the log is the base of the exponent, and these two things switch places. So it'll go 12 to the 2 is equal to x minus 8 squared times 4. Now it's just algebra, okay? So this is going to be 144. If I multiply x minus 8 squared out, it ends up being x squared minus 16x plus 64. That's what I get by writing it twice and multiplying it out. And then I have to distribute this 4. So I have 144, hopefully I don't run out of room here, is going to be 4x squared minus 16 times 4. I'm not really sure about the 16 times 4 in my head there. I was doing really good for a second. 64x plus, yeah, there's no way in hell I know 64 times 4, so 256. Okay, then clearly I'm going to want to subtract 144, so I'm going to go 256 minus 144, and I get 0 is equal to 4x squared minus 64x plus 112. 112, is that divisible by 4? It is. 64 is divisible by 4. So the first thing I can do is divide by 4 here and get 0 equals x squared minus 16x plus 28. That's going to be a lot easier to deal with. Yep, I sure did. I ran out of room, so I'm going to get a little tricky here. I'm going to use the bottom of the page. I'm an artist, really, Janelle. Okay, so this is x equals... I need two things that multiply, well, these will be x's, of course. Two things that multiply to give me 28, where I can turn them into a 16. I think 7 and 4, but that's 11. It's going to be 14 and 2. 14 times 2 is 28, and I can turn a 14 and a 2 into a 16. So this would be 14 and 2. They have to be the same sign, and I want it to end up negative. So I'm going to get x minus 14 and x minus 2. That would be x squared minus 2x minus 14x is minus 16, and then that would be plus 28. So I get x equals 14, and I get x equals 2 as my two answers. Now the one thing I got to do, every time it's a log equation, you don't have to do this with exponential, but with logs, I'm going to have to make sure that this doesn't turn into be a negative. I mean, that doesn't put anything in there, but I can't have this set of parentheses be negative. Put a 14 in there. 14 minus 8 is 6. That's okay. Put a 2 in there. 2 minus 8 is negative 6. That's called an extraneous solution. I got to cross it off. 14 is my only answer. Okay? I'm just going to make one long video here, so I'm going to... Oh, wait. I got another one to do. The artist. Okay, so now I do have logs on both sides here. So this problem won't get finished by rewriting. This problem will get finished by setting things equal to each other. What I got to do is make them one log statement first. So this first one, I don't have any numbers that I have to put up as exponents, but this will be a fraction because of this minus right here. That's going to put this in the denominator. So I will have the log base A of a fraction, where x minus 1 goes on top and x plus 10 goes on the bottom. All right. The second one, I don't have any numbers in front, so I don't have to write any exponents. I have another fraction. So this will be the log base A of a fraction. The positive term goes on top, x minus 4, and the one with a minus in front of it goes on the bottom, x minus 3. Okay, so now I have log base A of arguments. So it's just like this one now. And I can just write x minus 1 over x plus 10 is equal to x minus 4 over x minus 3. Now we're just solving that. In order to solve what's called a proportion, you cross multiply. Or you could do it one step at a time and think, okay, I want to get x plus 10 out of the denominator, so I multiply both sides by x plus 10. Then I would multiply both sides by x minus 3 to get it out of there. We're going to end up cross multiplying. So I have x minus 1 times x minus 3 is equal to x plus 10 times x minus 4. Okay. Let's multiply this stuff out and solve. So this is going to be x squared minus 3x minus 1x is minus 4x plus 3. And this one is going to be x squared minus 4x plus 10x is plus 6x, and that's minus 40. Okay, solving this, the first step I do is subtract x squared, and they just cancel. And then let's push everything over that way. So I'm going to get 0 here is equal to, when I add 4x, I get 10x. And when I subtract 3, I get minus 43. Okay, add 43 and I get 43 is equal to 10x. And when I divide, I get 43 tenths, or 4.3. So x is equal to 4.3. Now I got to check to make sure that this 4.3 won't make any of these negative. So let's try it. 4.3 minus 1, that's okay. That would be positive. 4.3 plus 10, that's definitely positive. 4.3 minus 4 is positive 0.3. That's close, but it's okay. And 4.3 plus 3 is good to go. So your answer is 4.3. All right, I'll go to the next page.